We would like to welcome Vikash Pandey. Welcome, Vikas. Vikas is an empathetic leader working with people and technology in the area product development, consulting, support, and operations for 20 plus years. So he has very extensive experience of 20 plus years, as we have seen all the areas like product development, consulting, support, operations, everything. Oh, wow. So Vikas would be speaking on microservices explored. So microservices, which we know that very hot in the market, web services, microservices, everything is going from monolithic structure to microservices structures, and lots of jobs coming up for APIs, microservices, these all things. So the most awaited session and most hot topic in the market. So to know more about Vikas and to see his video interview, we can go on this URL and you can connect him on LinkedIn. There is LinkedIn profiles here on speaker panel uh, in our website, GTR website. So welcome Vikas, stage is yours.
Thanks so much, Abhay,
Thanks so much
for
for
for such a nice
nice
introduction.
introduction.
Good evening, all,
Good evening
and
all
welcome.
and welcome.
Never mind. All right. So, knowing that you all are spending your weekend evening to this conference, that means, and that proves basically you all are curious like me. Even after 20 years, I don't feel satisfied until I learn or conclude my day with some learning. Whether it is about technology, about people's motivation, aspiration, anything that I need to have that one learning before I conclude my day. So I'm very happy to be here with a set of people who are curious. It's my kind of people. So if Abhay approves, we can get started. Otherwise, we still have 1 minute. If we can wait
We
for that minute and then
that minute and then
sure.
we have plenty of attendees. We can start, not a problem.
All right.
All right.
So let me share my screen and then we'll get started with my presentation. Confirm me back when you all see my screen. Anyone would be fine.
Yes, we can see.
Perfect. Thank you.
Perfect. Thank you.
All right. So the topic that we are going to talk about in next 45 to 50 minutes is microservices, and why we are saying it explode, because it will not be a preaching kind of session where I'm going to preach you how to do it. No. The session would be about what it is, why it matters to us, what are the pros and cons of every available option that we have for most of the aspects of microservices. And then finally, before we conclude, we will have few minutes at the end where I would love to hear from you either through Slido or if you want to be interactive. So the agenda is, what is microservices? Why should it matter to us? And what are the trends that are supporting microservices, right? If there is something which is getting hotter and hotter day by day, there must be certain trends that must be supporting this particular topic or concept or technology. What are the advantages? At the same time, what are the concerns? Because microservices, like any other technology or concept, cannot be the silver bullet, right? There must be some concerns. But the good part is all these concerns can be mitigated, and we will cover a few of them. An interesting differentiation between services and libraries, and few important aspects of microservices like service discovery, service registration. How do we deploy that? And then one of the most important aspect that I have dealt with is data handling in this new world of microservices. Then we will talk about how we will be strategizing and looking at when we are migrating from a monolith to microservices. And after that, we will share our various perspectives. Once I am done, I would love to hear from you what you think about microservices. All right, so let's get started and dive into it. Before that, who am I? I'm 43, married with a son. I'm residing in Pune, an Indian citizen. My strengths are positivity. I'm a maximizer. I don't know why, but I have that eye and the feeling or heart where I can really identify people who can and create a winning team, and then we maximize the outcome. I'm a developer and I'm an arranger, as well as I take the responsibility, accountability of anything and everything which I claim that I'll deliver. 20 plus years in industry, out of that 13 plus years, that means 65% of my career is with my current company, that's FIS. I have dealt with or managed consulting, delivery, support. I'm a result oriented personality, and my focus is on solving problems than discussing about the problems. I'm a technology enthusiast with strong interest in people and their success and aspirations. Before FIS, I spent time with Fidelity Investments, iFlex Solutions, one-off software development, and e-enable technologies. I'm a consistent learner, and I build and share my views through my LinkedIn posts, through my blogs. So it's kind of a practice. I learn and then I share. I learn and then I share. I'm a strong advocate of DevOps, cloud, and microservices. When it comes to implementation, I'm an inbox thinker, right? You must have been hearing the term or the word called out-of-box thinking, right? Everybody wants you to be out-of-box thinker. It's great idea. I'm a certified out-of-box thinker as well. But when it is just about thinking and exploring, I'm perfectly fine with being an out-of-box thinker. But when it comes to implement, I advocate for inbox thinking because it says that way I can really find out a better utilization of the available resources that I have rather than seeking and asking for more and more resources. Resources does not mean only people. Resources means technology. Resources mean tools. Resources means my team members. Resources means support from my management or organization. So in that case, I try to be an inbox thinker rather than an outbox thinker. Now, the meaty piece. What is microservices? So Martin Fowler, the father of this concept, talks about it's an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms such as HTTP resources, API interfaces. IBM describes it as a cloud native approach to build application from loosely coupled and independently deployable smaller components or services that have their own stack. That means they can be built in their own technology stack, Python, Java, .NET, JavaScript, Node.js, Go, that uses REST API and other form of communication to connect to other services. And these are sorted by business capabilities and separated into need to know chunks via bounded context. So every service is bound within its own context. Something that not purely me, but my experience is that microservices are an application design architecture with a philosophy based on building independent components that all connect via API. It could be HTTP, Thrift, or REST to reduce the complexity, to increase the scalability, and allow applications to be distributed with more ease than traditional monolith style programming architecture. With this, let's see why it matters to us. Why should microservices matter to me or matter to you? So there was a survey or a poll conducted by Vincent Bond on behalf of API management. That poll was among 200 senior IT leaders of organization with more than 1,000 employees. And here are a few numbers. 89% of technology leaders agree that companies that are not able to effectively support microservices will be less able to compete in the future. The primary reasons cited for adopting microservices are improvement of security, increased development speed, that we all will agree to it, increased speed of integrating new technologies or adopting new technologies, improved infrastructure flexibility, and improved collaboration across teams. That's my favorite, and I have seen it, experienced it. Availability, security, performance, and scalability are given the highest importance. Now, in these days, the availability is taking a lot of importance. Most of senior IT executives are giving availability a higher rating than anything else, because if our systems are available like Netflix, even if I'm not completely running the feature, I can really run the semi feature, which is not fully delivering what I committed, but something which can offset it. Faster development speed, increased collaboration, and reduced deployment risk are the key desired outcome for adapting to any new technologies, right? Why should I be adapting to a new technology if I don't have any benefit? The benefits that reason out why we adopt new technologies are development speed, collaboration, and deployment, reduction of deployment risk. The survey also notes that 83% of organizations are relying on open source software to become more agile. The reason is things which have already been developed, let's take it, use it. If it is not fitting me 100%, and if I have really excellent people with me, we will be editing it or mutating it to our need, right? We can make it fit for our purposes. The technologies which are commonly used in the open source space are databases. We are hearing a lot of NoSQL and a lot of NoSQL implementation, the commercialized one as well, right? When I started, it was MongoDB, which was the hero. Now CouchDB, CockroachDB, and then so many DBs, right? The containers, API gateways, infrastructure automation. We started with Ceph Puppet, now we are with Terraforms, Ansible, and so many other, right? Container orchestration, Kubernetes, there are multiple variations of Kubernetes as well, or I would say competition of Kubernetes as well, right? Continuous integration and continuous delivery tools. So CI/CD is also a very, very important aspect to this. So it's not only all the good things have been noted, there are a few concerns as well. So people who participated in the poll, they found that there are certain things that they want to put it under challenges or concerns. And those concerns are, how would we ensure security when we know things are distributed, right? Microservices means to completely solve a business problem, I now have multiple moving parts. How do we ensure the security among all these parts playing together? Integration with legacy application, right? We have not completely transitioned or moved from monoliths to microservices. We are in the transition or the journey phase, right? And we are still living with and connecting to those legacy and monoliths. How do we integrate that? That they raise it as a concern. The complexity of management, right? Since multiple players, by default, the complexity of managing them, making sure that they interconnect with each other properly comes into play. Updating API documentation. Despite all these concerns, however, more than 80% of the survey respondents who have adopted to microservices report that their organization performs well against metrics of development efficiency, because microservices and DevOps suggest that people should come together, break the silos, right? Hence, they see the development efficiency go up, the ability to use new platforms, collaboration across team, and sharing of services across applications. In my opinion, the foundation to get into microservices world or to fully utilize its capabilities is to have a strong DevOps culture embedded in the team. Then we are going to utilize or take the best out of microservices journey. The next one is, what are the trends that are supporting microservices? In 2019, trends that supported microservices, the prominent and pervasive one were test automation, incident response, continuous deployment. In 2020, the trends are high microservices market growth, 22.5 in US and overall 27.4. The cloud adoption, right? Organizations and their software delivery staff is moving away from locally hosted application and shift into the cloud. Today, you talk to anybody, even the people like me or my experience, whom we may call the baby boomers or legacy or monoliths, we are also encouraging and enjoying getting into the cloud. So we are also encouraging, we are also supporting, and we are also excited to move into that new world. Observability tools. Companies recognize how important observability is for distributed microservices based architecture. And observability, on the space of observability, we see a lot of tools coming into play. They are really good ones, and they give more than just a dashboard or a metrics detailing. They give us the insight. So when multiple players are in the play, it's more important to observe, identify any risk, and proactively fix it. Okay, than looking at metrics after the game.
ऑक्शन कसं करायचं सांगता का?
Web services frameworks are coming up that will enable developers to use microservices, that will help them continue to evolve and offer development out of the box capabilities and implementation of the service design patterns and code automatically. So the industry is working towards where the design patterns and you pick and choose the design pattern, and the code will be, that means the skeleton code will be ready for you automatically, and then you are expected to feed in or put in the meaty pieces, your business logic into it, and rest everything is ready for you. So that's one of the prominent trend that is encouraging people to get into microservices world. Basically, a shorter development time, increased demand for frequent updates to the application. We know for multiple things we are the consumers, right? And we know what we want. Our temperament has been reduced because we know the technology and the landscape is such that our demands can be fulfilled or our wishes can be fulfilled much faster than 10 years or a decade ago, right? Hence, our customers also behave similar. They demand or they request or they ask for frequent updates to applications in response to that user demand for interactive, rich, and dynamic experience on various platforms. Microservices can support the frequency of this kind of demand. It also goes well with the need of scalability and agility to the applications, having high availability, scalability, and ease to execute on the cloud platform. So these are the trends that are supporting microservices in last 2 years, and people are acknowledging it, and they know that there are trends, there are support from the industry, from the players. Hence, they are feeling more comfortable to begin their journey on this landscape. Advantages, sort few concerns, and mitigation. How will we be mitigating that? So few advantages of microservices, because the microservices function independently. Each component can be built in whatever language the developer of that component prefers, right? And we are seeing it, right? Few of the services are developed in Java, few in .NET. Hence, we are increasing the scope. We are giving the option. That means people can play at their best in this entire game, right? If I have a 10 people team, 3 are good at Java and 4 are good at .NET technology stack, I don't have to ask them to get trained on .NET to contribute. They can write their own piece in the language of or framework of their preference. Individual components can be updated on their own since their internal operations is inconsequential to the app as a whole. As long as they report back the correct data, the app will continue to work. That means you don't break, but you can enhance yourself, right? You can't break the contract because many people depend on you. You can extend, you can give the support of the older contract as well as you can extend that contract to as a new contract or new API. But till the time you are meeting the contract, you are free to update and upgrade yourself as a service. Scaling can be done to each individual component, saving time and computing resources spent replicating entire applications to account for load on a single component. A component no longer meeting the need of its application can be replaced without affecting the application or the solution as a whole. Applications can be decentralized between multiple cloud providers, servers, and other services, both local and remote. The challenges that we need to look out for is during initial stages, it's the complexity because as I said, right, monolith are big, but in number it is only one, right? So auxiliary services will be much more in control. But when things breaks in pieces, the management cost goes high, the complexity goes high. So during initial stages, the complexity is higher, the number of services and its deployment complexity. Until this has been sorted out, the recommendation is we should go slow. And go slow means build during that slow period, build a strong DevOps foundation in your organization or team, and then you are ready to run to your speed on this journey of microservices adoption. Distribution cost, increased total latency across system performing the business functions. We all know multiple pieces. There must be interconnectivity lags. There must be interconnectivity cost. So that will come in play, and that comes in play. So we have to be carefully considering the number of microservices and their interconnectivity and dependency. And that's where the concepts like, should we all be processing the entire business functionality sequentially? Or should we be doing it based on events, right? Reduction of reliability. Since more player, more moving parts in the system, the reliability suffers. Concepts like service mesh, observability, and utilization of those tools could help. So we know that reliability suffers, but observability gives us an opportunity or an insight to see it and proactively fix it so that we don't land into the known risk or the visible risk. Any services can call any service. There is no restriction at all. Hence, a solid version strategy of API is a recommended mitigation. Without that, we will be in a thick mess. Or think of changing strategy. Change strategy. Versioning an API is like, so there are two concepts. You version your API, or you think about or take this problem from a different perspective called change strategy. So versioning an API is like having your age in your name. And then comes the fallacy of nested resources. If a resource John32, that means represented in REST format /John32, has a nested resource child called John32 child. Now the question comes, is the child resource of version 32 as well? Or is it a child when John was at version 32? Right? What if the child is changing version regardless of John 32? So you see the problem, right? If we go with the API versioning. In a survey, it was found that and this is called point-to-point versioning. It was found that point-to-point versioning, which is the strategy employed by most web API developers today, is 45% more costly. You can see the PNC of parent-child, right? And child's child and all, and the version, right? 45% more costly with 4 different APIs versions than a compatible versioning strategy. While compatible versioning strategy has a higher initial cost, over time it provides huge cost savings. Change strategy embarrasses compatible versioning strategy. So I would prefer this group to go and do a search on compatible versioning. In first or second blog, you will find a very interesting illustration which will clarify compatible versioning and its analogy against typical point-to-point versioning, and it will clarify that in your heads, and you will start embracing why should we be moving towards compatible versioning than point-to-point API versioning. So services and libraries, a very common query that comes into mind when we talk about microservices. The analogy that I have used is services are like your Lego blocks. If you are creative enough, you can use those blocks and create artifacts of your need, your choice. Libraries are pieces of your jigsaw puzzle. If any piece is missing, your entire artifact or your design is not getting fully created as you expected. So services loosely coupled, easily upgradable, libraries tightly coupled, complicated jars. So componentization via services. team must prefer distributing components as service rather than libraries. We had been doing it, we used to do it, but now it's time to move away from libraries to components so that that component can fit into as a building block into anybody's creation or creativity. Now comes the thick pieces, like what all important aspects that we should be looking at when we are starting or thinking about microservices, right? And these are the pure technical details, like how do we discover services? If there are 5 microservices deployed for me, how the service A or service 1 will discover service 2 or service 2B? So there are few options that we have: client-side service discovery, server-side service discovery. And here in few bullet points, I tried to capture the benefit and the challenges and how we can mitigate those. So when you are using a client-side service discovery, the client is responsible for determining the network location of available services instances and load balancing requests across them. If you sit into any of the microservices training, you must have come across Netflix Eureka, which is a service registry. It provides a REST API for managing service instances registration and for querying available instances. You must have come across Netflix Ribbon as well. It's an IPC client that works with Eureka to load balance your request across available service instances. Relatively straightforward, and except for the service registry, that's Eureka, there are no other moving parts. So easier to implement, easier to manage. Since the client knows about the available service instances, it can make an intelligent application specific load balancing decision, such as using hashing consistent. So if you land into a situation or a requirement where you as an application needs to decide the load balancing strategy, your choice is client-side service discovery. A significant drawback of this pattern is that it couples the client with the service registry, right? So client knows the service registry and it consumes that implementation. So that means it's tightly coupled. One must implement the client-side service discovery logic for each programming language and framework used by our service clients. When we are using server-side, the client makes a request to a service via a load balancer. The load balancer queries the service registry and routes each request to an available service instance. The AWS Elastic Load Balancer that we must have been hearing, or if you land into that space, you are reading about or you are exploring about ELB as a very, very common server-side discovery methodology. So ESB is an example of server-side discovery router. Some deployment environments such as Kubernetes and Marathon runs a proxy on each host in the cluster, and the proxy plays the role of server-side discovery load balancer. So Kubernetes and Marathon is having their own implementation and they expose it as a proxy. They host it or they put it on each host in the cluster, and that component, proxy component, does the job of server-side client discovery. The service registry is the key part of service discovery. It is the database containing the network location of service instances. For example, if you are reading about or hearing about Kubernetes, you must have heard about etcd. The alternates are Consul, and if you have ever gone through Kafka or big data space, you must have heard about Apache Zookeeper. Next is service registration. So if something has to be discovered, prior to the discovery, it has to be registered with someone. So what are the options that we have? We can self-register ourselves as a service, or we can use a third-party registration service. So when we are doing self-registration pattern, a service instance, that means I as a service instance, is responsible for registering and deregistering myself with the service registry. Netflix OSS Eureka client. Again, if you are have been doing any microservices training, you must have come across Eureka client. You might have done just by enabling it with annotation, but that's what it is. One benefit is that it is relatively simple and does not require any other system components. However, one of the major drawback is that it couples the service instance to the service registry. You must implement the registration code in each programming language and framework used by your service. How about the third-party registration? The third-party registration pattern, a system component known as service registrar that comes into play and handles the registration on our behalf or the service's behalf. The service registrar tracks the changes to the set of running instances by either polling the deployment environment or subscribing to events. The open source registrar project and Netflix OSS Prana are example of service registrars that has been implemented by open source as well as Netflix. A major benefit is that the services are decoupled from the service registry. You don't need to implement service registration logic for each programming language and framework used by your developer. What you need to do is you need to consume that registrar and register yourself. One drawback of this pattern is that unless it is built into the deployment environment, it is yet another highly available system component that we need to set up and manage and treat it like as a pet, because if this blows up, our entire architecture blows up. The deployment one of the aspect while we are thinking about microservices is how do we deploy it, right? So a microservice application consists of hundreds, even thousands in certain cases, of services interconnecting, playing together with each other, right? Services are written in variety of languages and frameworks. Each one is a mini application with its own specific deployment, resources, scaling, monitoring requirements. That means each service is an application, right? That's the beauty of microservices, right? Multiple service instances per host is one option where we are saying that we will get one host, either virtual or physical, and we will run multiple services on that one. Each service instance runs at a well-known port on one or more hosts. These hosts requires pet-like treatment because they are important. They are running multiples of my service instances. Hence, I have a lot of my investment into it. Hence, I have to take care of them like a pet, not as the cattle, right? So each service instance to be a process or a process group, and multiple services instances in the same process or process group. Relatively efficient resource usage because one virtual machine or one physical machine, multiple processes are running there. That means they are trying to fully utilize that machine. So relatively very efficient resource usage. Deploying a service instance is relatively fast. Starting a service is usually very, very fast because it's only one. We either start a process or we bring down the process or process group. The problem here is there is no or little isolation of service instances, right? They all sit on the one machine, so they are not isolated from each other. If that virtual machine fails, everything goes for a toss. Unless each instance is a separate process, they may interfere. While we can accurately monitor each service instance resource utilization, we cannot limit the resource each instance uses, which we will see in cases of containers. We restrict, right? On a given machine, multiple instances of a service is running, but they are running in their own world called containers. And we restrict the usage by the container of the entire infrastructure of that machine. A stronger dependency of operation on development, as there will be a technology specific deployment instructions to be passed on from development to operations, leading to increased risk of deployment errors. There is another way or variation of deploying is service instance per host. So one instance per host, either virtual or physical, right? Or even container, right? We package each service as a virtual machine image, such as Amazon EC2 EMI. There is Animator, there is Package IO, are the technologies that help us build virtual images. Few people or organizations have taken it a little further, like BoxFuse builds secure and lightweight virtual machine images that are fast to build, boot quickly, and are most secure since they expose a limited attack surface. Initially, when we were comparing virtual machines with containers, we always said that the virtual machines are not lightweight, they are heavy, they take a lot of time to boot up, and those things. So Boxfuse took up that challenge, and now they have resolved those challenges, and they are enabling us to build lightweight and secure virtual machine images. Cloud Native has a project called Bakery. It is a SaaS offering for creating EC2 AMI instances. We can consume it as part of our CI pipeline. We invoke Bakery API, passing in the required data. What it will return us is a created EC2 EMI of our microservice. Each service runs in complete isolation because one service, one host can leverage mature cloud infrastructure with load balancing and auto scaling coming along by default, since we are using low cloud infrastructure. Encapsulates our services implementation from technology. It is a little bit less efficient utilization of resources because we may not be able to size it, right? That my service will be taking this much of RAM, this much of space, and all those things. So we always give little more. That means we will be going back to the virtual machines era where we are always securing for the future by giving extra to that particular application. Each service instance has the overhead of entire virtual machine. That means even if it is not thoroughly utilizing that machine, it sits on that, including the operating system. Deploying a new version of the service is usually slow. Virtual machine images are typically slow to build due to their size. In the next slide, we will see that this, I'll not call it a myth, but this fact has been challenged, and the solutions are there which blurs this differentiation between virtual machine and containers. And the response to virtual machines image typically slow to build due to their size, and the response of the industry was containers. So let's see what we get out of container. So we can instantiate, or we can put our services in a container. That means one instance per container. Each service instance runs in its own container. The process that are running in a container have their own port namespace, root file system. We can limit a container's memory and CPU utilization. Examples of container technology include Docker and Solaris zones. Our services need to be packaged as a container image. It's a file system image consisting of application and dependent libraries. I hope most of you must have tasted the flavor of Docker, or at least looked at Docker file, how your delivery team or development team builds it. Containers isolate our services instances from each other. We can easily monitor the resource consumed by each container. Also, like virtual machines, containers encapsulates the technology used to implement our services, since we say package it all in the container. Don't depend on operating system. Okay, so it's like a completely self-sustained and contained image. Just boots itself up and does not depend on anybody and can run in its own. The container management APIs also serve as the API for managing our services. Containers are lightweight than virtual machines. Containers is not as mature as the infrastructure of a virtual machine. Containers are not as secure as virtual machines, since the containers share the kernel of the host operating system with one another. We are responsible for undifferentiated heavy lifting of administrating the container images unless we use industry solutions like Google Cloud Engine or Elastic Container Services. The advancements are aiming to blur the distinction between containers and virtual machine. The example or the company which has taken the challenge and blurring this is Boxfuse. Its virtual machines are fast to build and start. The Clear Container project aimed to create lightweight virtual machines as well. So I'll not be surprised if in few years we will go back to virtual machines, but those virtual machines are, or VMIs, virtual machine images, but those virtual machine images are fast to build and fast to start. At the same time, they will give us the security that we want, that typically virtual machine provides. The hottest one these days, we must be hearing serverless. AWS Lambda is an example of serverless. That means what serverless says that you think about your business, you write your code, don't get bothered about the infrastructure or the running infrastructure of your application. We will get it for you when you ask for it. I'll create it for you, run your business, shut it down, give you back your responses. So AWS Lambda natively supports languages like Java, Go, PowerShell, Node.js, C#, Python, and Ruby, and provides runtime API, which allows us to use any additional programming language to author our functions. The request-based pricing means that we only pay for the work that our services actually perform. Also, because we are not responsible for the IT infrastructure, we can focus on developing our application, which is our expertise, right? Few significant limitations, not intended to be used to deploy long-running services. The max limit is, in my opinion, it looks like 300 seconds. That means anything running beyond 5 minutes will be terminated abruptly without any consequences on AWS. The entire consequence will be on us, right? So that's strongest limitation, that we should write our application or business logic that should run well within 5 minutes max. The request must complete within 300 seconds. Must be written in one of the supported languages. Services must be stateless, and services must also start quickly. So it's for, that means in my opinion, we are going towards functions as service, right? If I can write a very precise function which runs well within 300 seconds, and I can write it in those supported languages, I can get myself away from infrastructure considerations and consume or start using serverless. The next most important one happens to be data handling. You know, right? In microservices, the most critical topic is how do we handle the data when things are distributed, when services are distributed. And a pattern that's been suggested most of the time, or a good design pattern, is your service should have its own database. But the challenge comes when I have to live with the monolith as well as microservices. How do we handle that, right? And different type of microservices choose to use different sort of set of databases, right? Because of genuine reasons. If some services are good and they think that they are capturing social media or streams, they prefer NoSQL, they prefer Graph. But if they are transactional or query based, right? A lot of requests to retrieve data, then they prefer SQL. So it's a polyglot persistent architecture of data storage has many benefits, including loosely coupled services and better performance and scalability. However, it does introduce some distributed data management challenges, and those challenges we will talk about it. So two-phase commit that we usually have to have in the world of SQL is not a viable option in model application. The CAP theorem requires us to choose between availability and consistency. And what industry is responding to that choice or the poll is availability is usually the better choice. Moreover, many modern technologies such as most NoSQL databases do not support two-phase commit. Another challenge is how to implement queries that retrieve data from multiple services, right? Somewhere, even if all these components or applications or services are working, I need to give a holistic or a combined view of it, right? And I may need to require to pull data from multiple database instances of these microservices, which are managed in their own world. So the response could be we may retrieve data using an application side join, but that's not the most optimal solution for the various situations. One of the solutions is to use an event-driven architecture. In this architecture, what happens is a microservices publishes an event when something notable happens, such as when it updates a business entity in itself, and then other microservices which are subscribed to those events, they receive that event and as a reaction to that event, they perform their own business logic, update their business entity, which might or might not lead to another event being propagated down the system, right? So it's like I got impacted, I made the change, but I know you, three of you are also interested in the change that I have just done in my system. Because you depend on me, I publish another event which you are subscribing, and you make those changes and you decide whether you need to percolate it down or not. The important thing to note that the transaction across microservices are not acid. They offer much weaker guarantees such as eventual consistency. And eventual consistency has been accepted in industry now. This transaction model has been referred to as the base model that trades some consistency for availability for dramatic improvement in the scalability, right? It enables the implementation of transactions that span multiple services and provide eventual consistency. Another benefit is that it also enables an application to maintain materialized views. The programming model is more complex than using ACID transactions. Often we must implement compensating transactions to recover from application level failure, because one failure might have a ripple effect. Application must deal with inconsistent data. The subscriber must detect and ignore duplicate events as well. So it's a complex data model, but it comes along with microservices, right? There are few ways to achieve atomicity. If we are really strict on atomicity, that no, I'm fine with eventual consistency, but I am looking for atomicity as well. So the options are the database as a message queue, publish events using multiple step process involving only local transaction. This approach eliminates the need for 2PC. That means two-phase commit, by having the application use local transactions to update state and publish events. That means you will design one of your table as an event table, and rest all that will drive or derive everything for your actual business responses. Transactions log mining, the events to be published by a thread or a process that mines the database transactions and commit log. The transaction log miner thread or process reads the transaction log and publishes the event to message broker. Event sourcing, which happens to be the most used these days, rather than storing the current state of any entity, the application stores a sequence of state changing events. The application reconstructs the entity's current state by replaying the events. Whenever the state of a business entity changes, a new event is appended to the list of events. Since saving an event is a single operation, it is inherently atomic. This event sourcing solves one of the key problems in implementing an event-driven architecture and makes it possible to reliably publish events whenever state changes. As a result, it solves data consistency issues in microservices architecture as well. Because it persists events rather than domain object, it mostly avoids object-oriented relational impedance mismatch problems, like your ORM and the need of your database. Also provides a 100% reliable audit log of the changes made to a business entity and makes it possible to implement temporal queries that determine the state of an entity at any point in time. Since it is capturing the event that ultimately changes the state, it gives us more detailed control on what has happened at what time to a given business entity. Our business logic consists of loosely coupled business entities that exchange events. This makes it a lot easier to migrate from a monolith application to a microservices architecture. We can use events to maintain materialized views that pre-join data owned by multiple microservices. The service that maintains the view subscribes to relevant events and updates the view. That means we will write a service whose job is to just monitor all the databases managed by the services of its own interest to create a materialized view. And then accordingly, because of any changes there and its subscription model, it will pull the data and updates its own database or materialized view, so that the reporting will be against this database than individual microservices database. The approach solves the challenge of how to implement queries that retrieve data from multiple services. All right. How do we go when we talk about we are strategizing to move from monolith to microservices? So the first advice or first learning that I had is we should stop the temptation to rewrite a monolith to a microservices in a big bang. It cannot happen that we will rewrite everything in one go. What Martin Fowler reportedly commented that the only thing a big bang rewrite guarantees is a big bang. One application modernization strategy is the strangler application. What we do here is we gradually build new applications consisting of microservices and run it in conjunction with the monolith. Over time, the amount of functionality implemented by the monolith application shrinks until it either disappears entirely or it just becomes another microservice. Here are a few strategies of doing this. We should stop digging when we are in a hole. That means we are considering a monolith as a whole. We are already in a trouble. We should not be digging it further. That means when we are implementing new functionality, we should not add more code to the monolith. Instead, the big idea is with this strategy is to put that new code into standalone microservices. There are two additional components to this kind of strategy: a router that receives and redirects the legacy request to monoliths and new functionality requests to newly added microservices, and a glue code which integrates the service with the monolith. We still need to integrate with the monolith, right? Because everything has not been microservicized. A microservice can access the monolith data through either of the below listed strategy, and I have experienced all three of this. Invoke a remote API provided by the monolith. This happens when we are really exposing or writing a wrapper API on top of our monoliths, which you might have also been experiencing these days. Access the monolith database directly. I did it for a few of my projects because I was not able to write the API layer. Maintain its own copy of the data, and that was temporary. After a few months of directly accessing database and convincing the stakeholder that we should write the wrapper, we moved there, but we lived in both the worlds. Maintain its own copy of the data, which is synchronized with the monolith database at a frequency, right? I can carve out my own database for the service and make sure that there is a sync between monolith and my database so that any changes that comes through the monolith also gets synced into my database instance. The biggest benefit of stop digging strategy is it prevents the monolith from becoming even more unmanageable. The service can be developed, deployed, and scaled independently of the monolith. However, this approach does nothing to address the problem with the monolith itself. Correct, we are writing the new pieces differently, but how would we go about if the mandate is fix the monolith problem? So here is a piece of advice. To fix a monolith, the solution is to break it in layers. And we have been seeing it, right? That we break a big application into front end, back end, database. These layers very usually comes into play and into our mind, right? Here is the front end, here is the back end, here is the DB access layer. There is another solution that could be to start extracting services out of the monolith. In my opinion, the good idea or approach is to start with few modules that are easy to extract and less business centric, like authorization services, authentication services, logging services, right? Anything which is more in technically in nature, easier it will be to extract it because we will not be disturbing the business and people will be confident, okay? This will give us an experience with microservices in general, right? We are building a microservice and the extraction process in particular. Then we know from where all we need to extract code to take few pieces out And after that, we should extract, after we are built up or we are ready with this experience and expertise, then we should start looking at modules that will give us a greatest benefit. That means business modules, which we can take out as a microservice. All in all, final words for this session. Microservice architecture is not a cure for all our software problems. If we think that we can run a short-term microservice project without previous experience, we are probably wrong. However, if our business is based on scalability and we take a minute is just a minute here, but basically it is suggesting that if we plan out the software architecture in the very beginning of a project, that means how the software architecture would be from the network topology standpoint, from component interaction standpoint, from security standpoint, if all these things are well considered, we will surely see the benefit of microservices. Microservices are great when it comes to solving scalability issue. In our State of Microservices 2020 survey, scalability issue got rated 4.3 out of 5, and performance issue average rating was 3.9. But the interesting fact is it has the potential to move into 4.4 for our scalability and 4.3 for performance. That means people are accepting that microservices fits the bill when it comes to solve the scalability and performance problem of the application or a business scenario. These days, the microservices plus serverless model is also on the rise, and we all know that JavaScript and TypeScript go well with the serverless. Hence, in that survey, it was found that 65% of the respondents say that they are architecting their microservices using JavaScript and TypeScript. All right, so that's me on microservices. I'm open for questions, or I would love to hear your perspective if you want.
I will just check Slido if we have any questions. Yes. So we have one question. I'll just share my screen. So there is one question. What would be the test strategy you would suggest for microservices?
Interesting. I think there was a talk today, right? I was interested in covering at least 1 or 2 slides, but I thought there is already a talk. So microservices testing is unit testing, then your component testing, then your contract testing. I recommend less time spending on end-to-end testing, more on contract and component testing. If you are certifying component working well within its own world and it fulfills the contract, that means they can interconnect with each other, we can give some benefit of doubt to our investment on end-to-end testing. And that's what my piece of advice is on. But if you are really interested, I will paste a link here or connect me on LinkedIn. I went through the testing strategies suggested by Martin Fowler on microservices, and it's a really good one. I just dropped the idea of inserting few slides because I saw there is already a session on microservices testing strategy in this conference. No questions. Thanks so much for the opportunity, and all the very best to all of you if you're taking your journey on microservices landscapes. Enjoy rest of the conference session. Thank you.
My screen is shared. So thank you so much, Vikas. So this particular conference has been brought to you by Agile Testing Alliance, DevOps Plus Alliance, and I Square IT. Our platinum sponsors are QA Mentor and Quality Kiosk. Product partners, Micro Focus, community partners, Selector Serve, Test Chat, the Test Chat, Fundu Tested, CSQA. Other sponsors are like Value Innova, IoTA Digital, QA Agility, Certify Me, and Elatform. So thank you so much for joining this session. Thank you, Vikas, for delivering this great session.